Hello everyone, in this video we are going to discuss the solution for maximum swap. So let's see how we can solve this problem. Alright, then let's study our question first. So in the question we have been given a number in the form of string. Okay, and we have been told that we can swap 2 digits at once. Okay, and we have to find the maximum valued number by swapping only 2 digits. Meaning we can swap only one time, and we have to create maximum value number by doing that operation. Okay, so let's take one example, our sample example 2736. Okay, so we have to do one swapping operation such that it become the largest number possible by doing only one swapping. Okay, so we can swap this, we can swap this, we can swap this, we can swap this, like this. Okay, let's count. We can swap this, this, and this. Then we can swap this, this, and this. Okay, and our last swap could be this and this. Okay, so this is how we can do multiple swappings. So a simple method or the name method could be, we try to swap each and every pair and see which of the following gave me maximum valued number. Okay, so for that I will need extra space, because in my example I may have got only 4-digit number which can be stored in our integer. But let's say if I have 20 length string or 30 length string, it won't be possible to store it in integer or even long. Long has capability of storing 18-digit numbers, so even long won't be able to store these numbers. Okay, so first thing, we will have to store all the result that we are forming. Also, for doing multiple swaps, it will take at least n square time. Okay, so that approach is not viable, so we have to move further. So there could be one more approach, that we find the next greater element. Okay, so 2736, we find next greater element is stored at which index? So index 1, index 3, because there isn't any number which is greater than 7. Index 3, index 3. Okay, such thing like this, and we just try to swap. Now this is at 0, this is at 1, we can swap it. Okay, so this could be one possible solution. Okay, such like this we can have multiple solutions. Okay, we can either swap this and this also. This is also one valid answer. Okay, we have improved our previous method, but it will still take memory, extra memory, at least on of more space. Okay, so we can improve it much further, and we can develop a more optimized approach for it. Okay, and how we are going to do this? Let's take one example. Let's say 9 9 8 7 5 6 6 3 1 7 7 4. Okay, let's say this is my number, and I have to find maximum number by swapping only once. So this time I'm going to store the last index at which one number is stored. What do I mean by that? Okay, let me write it first. 1 2 3 4 5 6 7 8 9. I'm going to store at which index this number has come last. Okay, so let's write it. all the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. Now let's write their indexes. So 9 come at 0. Okay. Then it comes at 1. 8 come at second index. 7 come at third index. 5 come at fourth index. 6 come at fifth index. 6 again come at sixth index. 3 come at seventh index. 1 come at 8 index. 7 come at 9 index. 7 again come at 10 index. 4 come at 11 index. Okay. Now I have the result at which all these elements come last time. Okay, now what I'm going to do with it? Now I know that on the leftmost side I have my most significant digit, and on my right hand side I have least significant digit. Okay, I have to make my most significant digit greater, and I don't care what happens to my least significant digit. Okay, I have to do some swapping like this, that my most significant digit becomes greater and least significant digit uh, decreases. Okay, I have to swap like this. All right. So when I have written the last indexes for all of these numbers now, I have written for which this number is existing at last. So let's go all over the array once again, and I'm sure that you will be able to see what I'm trying to tell you. Okay, so I reach at 0. I have 9. So 9 is already at maximum place. We travel again. We found 9 again, which means we don't have to swap anything. Now we reached 8. Now this 8 can be replaced by what number, so that this entire thing can become greater. This 8 can only be replaced by 9. If it is replaced by 9, then only this number will increase, right? So if I will see where is the 9, 9 has come at first index in the last time. Okay, if I will try to swap these two numbers now, 8 and 9, if I will swap them, then the overall value of my number will decrease. That's what I don't want. So at least the number that I have to swap with, for example, I had to swap 8 with 9, then the last index of 9 should come before, uh, should come after this 2. If let's say instead of this 6 I had 9, then I would have easily swapped this 8 with this 9. Okay, but this isn't the case here, so I'm not going to swap it, and I will move further ahead. Okay, now I have 7. Okay, so to make this entire number larger, I have to replace this number with either 9 or 8. Okay, even if I replace it with 7, the number's value won't change. I have to strictly increase my value. So I will have to either swap this 7 with 8, 9 or 8. First I will try to swap it with 9, then I will try to swap it with 8. If swapping with 9 is not possible. Okay, so I try to check with 9. Okay, it comes at first index, so obviously can't swap it. And now I check with 8. I have made a mistake maybe. So this should be right. So at 7, this 7, can it be replaced by 8 anyway? Isn't 8 anyway, because the 8 last has come at index 2. So we won't be able to replace it. So it will remain as it is. Okay, now we have 5 here. Now 5 can be replaced with either 9, 8, 7, 6. If we try to replace by any of these numbers now, we will increase the value of our number. If we will try to swap it with any other number now, we won't be increasing our value. Okay, so let's try to do it with 9. Can we swap it? No, we can't. Can we swap it with 8? We can't. Okay, now for 7. The last value for which the 7 has come is 10 here. So 7 is here and 5 is here. If we can swap them, the overall value for my number will increase. So I will do that. I will swap these two, and my new number will become 99877663175. Okay, so now I have the largest number by doing the math only one swap. Okay, if I could have done multiple swaps now, I would have been easily able to swap all the numbers and put it in the descending order. Okay, so this was one example. Let's take one more example. 5, 6, 7, 8, 9, 9, 7, 3, 3, 4, not 8, 5, 6, 6, 3, 2, 1. Okay, so this is my number now. Let's put the indexes 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's go from left to right and put the last indexes. So for 9 we have 0, for 7 we have 1, for 3 we have 2, for 3 again we have 3, for 4 we have 4, for 5 we have 5, for 6 we have 6, for 6 again we have 7, for 3 we have 8, for 2 we have 9, for 1 we have 10. Okay, now let's go over it again. Can we swap this 9? It's not required. Okay, now we will try to swap 7. 7 can be swapped with 9, 8. Okay, 9 and 8. 9 has come at index 0 and 8 hasn't come at all. So basically we can't swap 7. Now for 3. Which numbers can swap it? 9, 8, 7, 6, 5, 4. These numbers can swap it. So let's start with 9. 9 can swap it. 9 is already at higher place. It won't be necessary to swap it. 8 doesn't exist. 7. 7 has come at index 1. So it can't swap it. Now 6. 6 has last come at index 7. So definitely this 3 can swap with 6 to increase the number. Okay, so my new number will become 9, 7, 6, 3, 4, 5, 6, 3, 3, 2, 1. So this will be my new number. So that's how we have to perform swapping. First, find our last index, then go all over our array and try to check from 9 to that number. Is it possible to swap it? And if it is possible to swap it, then we swap it. Okay, and we have to swap it only once. So for that, we will need some boolean flag. Okay, so that we only swap it on once. Now if you think about it, if I put some count there, we can actually make it for more than one swap. Okay, so now let's code it. Okay, all right, then let's code it now. So first thing we will need is our LIDX array, which is last index array. So let's create that array. So vector int LIDX and y size 10, because we have digit from 0 to 9. Okay, now we have to travel our string array. Sorry, not string array, only string. Okay, int I equal to 0, I less than arr dot length I plus plus. Okay, now LIDX arr I minus 0, because this is my actual character which is going to be represented as index. It is going to store the last index at which this character is going to occur. Now, as I said before, I will need a boolean flag which is going to tell me if my swap has occurred or not. So initially it will be false. Currently no swapping has been done, so that's why. Okay. I equal to 0, I less than arr dot length I plus plus. That's it for the outer loop. Now what about the inner loop? We have started checking from 9, so we will write it like this: j is equal to 9. J is greater than arr I minus 0. And why this character? My j was already greater than this character. If it was equal to that, it won't matter if I will swap it or not. Okay, so for that, j minus minus, that's it. Now I just have to check if LIDX at that j is actually greater than my current index. If this is possible, then I can swap it. So I will swap using a temporary character arr I and arr I equals li not l arr li dx of j. That's it. Li dx, because this li dx array is containing the last index. Okay, temp, that's it. Now I have to turn my flag to true and break out from this loop. Now I have to check if flag equals true. If flag is equal to true, then break out from the outer loop as well. Now we have to create our answer array. But look carefully. We had done swapping on the original array. Okay, this original array. If I have done swapping on the original array, as in C++, strings are mutable, I have already made my answer array, isn't it? So do I actually need to create one more loop for me to create one more answer array? Do I have to? Actually no, I can just return this arr array. So that's it. This string arr is going to be returned from just here, and I think this will run. So let's run it. So we got successful submission for our sample test case. Let's submit it. So we got past all the test cases, which means our code is completely correct. Okay, so let's talk about its time complexity. So here you can see this is going to take O of n time. And now what about this loop? Some of you may be saying that it's taking n square time, but look carefully. We have j is equal to 9, and at max my j will run 9 times. Okay, because the digit will lie from 0 till 9. Okay, and my loop will run for 9, 8, 7, 6, 5, 4, and till 1. Not even not for 0. So only 9 times. So we can say that our loop will run O of 9 times, which is actually equal to O of n. So a time complexity is going to be O of n, big O of n. Okay, and what about my space complexity? I have used array, and if I have used array, it means that O of n space. No, not necessarily, because look here, I have taken the constant space. It has space only 10. It is not dependent upon the size of my array. So my space complexity is also constant. So my space complexity is constant and my time complexity is linear time complexity. Okay, so that's all for the solution of max answer, and I hope that you have understood it well. Okay, if you haven't understood it, I will recommend you to watch this video once again, and I'm sure you will be able to understand it. Okay, so that's all for this video, and I will see you in the next video.